Introducing the all-new state-of-the-art 4130 steel frame chassis for commuting bicycles, brought to you by A1 Frames. Engineered with extensive materials research, this frame will provide you with the greatest commuting experience without breaking the bank.
The bike frame is the most important part of a bicycle. It serves as the backbone of the bike, while changing its handling ability. Not only that, but a bicycle frame takes a ton of forces through riding. Even a commuter bike, used on sidewalks, roads, and pathways, must be designed with care to give a great riding experience, while being cheap. The weight of the rider and bad roads are only some of the obstacles that the frame will face. So, a well-designed frame will be the difference between a pleasant commute and hell.
Currently, the frame is constructed from 4130 chrome molybdenum steel tubing, commonly known as chromoly. 4130 steel has a high yield strength, more than enough to support the common loads bicycles must withstand. As well, 4130 is a tough material, able to absorb the energy of high-speed impacts. The frame is usually a diamond shape that can then be broken down into the front and rear triangles constructed from tubing. The tubing is formed from raw steel that is workable. Then the steel is stretched out into long, thin blocks by hot rolling back and forth through a set of rollers. The blocks are then cut to length, heated, and then molded into a cylinder shape called a round. The round undergoes further heating and is then rolled with high pressure, causing a hole to form in the center of the cylinder, which is then refined. Finally, the pipe is straightened. The finished tube can undergo butting at the ends where the thickness is increased. This is done to accommodate higher stresses at joints when welding. The tube members are then tungsten inert gas or TIG welded together using jigs to form the shape of the bike frame. Lastly, the frames are painted to provide protection from environmental factors such as corrosion.
What do commuters want from their bike frame? To start, the frame is the skeleton of the bike, supporting the other parts such as the handlebars, gears, pedals, and wheels. Not only that, the frame must also be able to support the weight of the rider, uneven roads, and unexpected obstacles. So, suitable bike frames must handle both high compressive and tensile stresses and also high bending stresses in use. In addition to high strength, consumers also don't want their bike to shatter if it falls down on its side or thrown around. The frame should be able to deflect when in collision or under other quickly applied loads, ensuring it doesn't undergo brittle fracture. This ability to plastically deform is called ductility. Furthermore, the frame should last longer than most of the other components on the bike and have a long fatigue life. Bikes don't come cheap, so when consumers purchase them, they expect it to be a long-term investment lasting at least 5 to 10 years with continual use. This functional requirement can be described as having a long lifespan, quantified with endurance limit. Apart from this, there are other specifications to be considered when manufacturing the bike frame. Being composed of hollow tubes, they're usually joined together through welding or with the use of lugs. The beams also have to be cut to the appropriate sizes and shaped accordingly. Therefore, the material selected should have decent machinability and weldability.
In deriving our material property indices, we had to make reasonable assumptions regarding the bike frame. First, the loading on the bike frame was modeled as a simple truss structure. A 95th percentile male was used as a benchmark for the weight on the frame, with a safety factor of 2. With this simplified calculation, a maximum stress in the tube can be calculated in the structure, allowing for our first index to be derived. This index will rule out any material that is deemed too weak for our application while considering cost. We also assume that the bumps and other loads were repetitive and could be used to test the fatigue life of the materials. We assume that the cyclic loading would be due to the daily operation of the bike. This allows us to select materials that are durable yet cost effective. Next, we've assumed the bike is manufactured with a tubular cross-section, uniform in thickness throughout the members, so we ignored butting of the tubes. Having uniformity in the cross-section, we can accurately determine cheap and high ductile materials, a crucial parameter to comfortable riding and safety during impact. In addition to tensile and compressive stresses, we wanted to account for bending moments in the tube. Assuming the total benchmark weight is applied to the middle of one tube, we can overestimate the flexural strength needed in the material while minimizing cost. However, with all these factors, the one that the average consumer cares about the most is the cost. We looked at currently available commuter bikes, and the average cost was around $150. With this in mind, we focused on trying to minimize the cost while fulfilling the functional requirements. But even if it's cheap, a bike that weighs 1,000 pounds is not what the consumers want. We had to strike a balance between cost and weight, so after narrowing down to a handful of cheap materials, we derived an index to minimize the mass of the remaining materials while maintaining the necessary strength. With these assumptions in mind, along with the aim to minimize costs, engineers at A1 Frames have developed these material performance indices to assist in material selection process.
Throughout the bike's lifetime, there are a number of effects that cannot be taken into account using the MPIs derived. The most significant problems one can come across are related to environmental effects. Consumers may use bicycles as a primary mode for transportation, and thus can be subjected to the effects of varying temperatures and precipitation. With some materials, corrosion can easily occur if the bike is left outside or used during snow or rain. Furthermore, being located in Canada, there are large temperature changes that occur throughout the year, from as low as -30 degrees to up to 50 degrees Celsius. Under operation in these extreme conditions, thermal expansion and contraction could occur. In cold conditions, the frame may start to behave in a more brittle manner. Stress corrosion and crevice corrosion could also occur in the welded joints due to localized annealing. Daily use of the bike will result in wear and tear. Depending on the conditions the bike is used in, loss of material and scratches could also occur through interaction with environmental debris and everyday factors. All of these small impacts result in the changing of material properties such as ductility due to the creation of defects.
Through comprehensive testing and research, A1 Frames have engineered the ideal commuter bike frame, constructed of 4130 steel tubing. Numerous materials have been tested at the A1 labs, namely magnesium and 6061 aluminum. However, steel outshines magnesium and aluminum in many classes of properties, given its low cost. This is due to the versatility of steel and its ability to control its properties through treatments and alloying. Steel frames are generally less harsh, providing a more comfortable ride due to its ductility, an essential aspect to the perfect commuter bike. As well, there is no frame material more durable than steel, able to withstand scratches, dents, and even bends, while retaining its structural integrity. Lastly, steel is a highly abundant material, easy to source, and even easier to manufacture, making it the perfect material for the perfect bike frame.
Bikes have developed drastically throughout their history, along with the advancement of engineering materials. Mainly, 4130 grade steel and 6061 aluminum have become common materials for commuter bike frames, known for their balance between strength, weight, and cost. For generations, steels have been the most commonly used material for commuter bikes, becoming lighter, cheaper, and stronger as the engineering of materials have developed. With the abundance of iron, the cost of production of steel will continue to decrease. As well, material engineers are finding ways to achieve strengths never before seen at a fraction of the cost. For these reasons, 4130 grade steel continues to be a staple in commuter bike frames, revolving the way we move.